Hi everyone, welcome to this video. So in this particular session, I want to take you through three questions that I've prepared for you. So these questions are coming from additional mathematics. So they are coming from a topic called quadratic inequalities or quadratic functions. Okay, yeah. So I want us to go through these questions that I've prepared. These questions come every year in additional mathematics paper 2. And when they come, they are always given 3 marks. Okay. And many students usually make mistakes and they would only get 2 out of 3. Okay. So today I want to explain all the methods that you're supposed to do for you to get these 3 marks. Okay. Yeah. So stay with me as I try to explain the concepts that you need to know under this particular question. Yeah. So the question says solve the inequality. So we have x squared minus x less than 6. So when you're solving these inequalities, you are not looking for the exact value of x. They are different when we're saying solve the equation, okay? When we solve equations, we're looking for the exact value of x. For example, if I have x plus 2 equal to 5. If they say solve this an equation, okay? So if I try to solve this equation, I'm looking for the exact value of x. But in such questions, we're not looking for the exact value of x. Rather, we're looking for the range of values of x for which the statement will be true. Which statement are we talking about here? X squared minus x should be less than 6. Okay? Yeah. So we're looking for a set of values of x. So what are we supposed to do? So there are basically 3 steps that you're supposed to carry out. And this is why the examiner will give you 3 marks here. Okay? So 3 steps, 3 marks. So what are these 3 steps? Okay. So the first step when you're solving these quadratic inequalities, the first step is to factorize. So you factorize the expression, okay, this quadratic expression. So they'll give you 1 mark for this. The second step is to simply state the roots, okay? You want to state the values of x where that expression can be 0. So you state the roots or the critical values. You state the critical values. The third step, you just want to write down the correct range, okay? So you're going to test, in fact. You're going to test, then you write down the correct what? The correct range. Remember I said you're not finding the exact value here. You're finding a set of values of x. So you state the correct range. So 1 mark for this, 1 mark for that. Then you have 3 marks, okay? Now, many students will get these 2 marks, but they fail to write down the correct range. Others try to guess. So today I want you to know how it's done, okay? Yeah. So let's begin. Let's begin. We're going to just simply follow these 3 steps. It's 3 steps that will give us 3 marks. Yeah. So let's start. So solve the inequality. So the first step, like I said, we need to factorize. But you can see this quadratic expression is somehow not in the standard form, okay? The standard form should be ax squared plus bx plus c less than 0 in this case. We should have a 0 there, okay? Yeah. So we need to rearrange it. Then we factorize. So the first step is to rearrange. So by rearranging, you can see we can simply take positive 6 to the other side. It will become negative 6. So we're going to have x squared minus x minus 6 less than 0. Okay? No mark for that. Okay? We are supposed to factorize. So let's factorize. So by factorizing, let's find the product, the sum, then we find the factors, then we can easily factorize. Okay, so the product, you simply multiply a and c. So a is a coefficient of x squared. So whatever is here is a 1. So 1 times c, which is negative 6 there. Our product will be negative 6. Sum is always equal to b. B is simply the coefficient of x, the middle term here. So negative 1 is in front of x there. So our sum is negative 1. Then the factors, the 2 numbers, we multiply them, we get negative 6. We add the 2 numbers, we get negative 1. So find 2 numbers. When you multiply them, you should get negative 6. When you add them, you should get negative 1. Usually there are factors of what? Negative 6. So those two numbers will be negative 3 and 2. Okay, so we are yet to factorize this expression. So let's write down these two numbers in terms of x, then they should replace the bx part. Okay, they should replace the middle term there. So I'm going to have x squared. So negative 3 will be written as negative 3x, positive 2, positive 2x, minus 6, less than 0. You know how to factorize here? By grouping. Okay, so this part and that part. Okay, so what are we going to do here? We take out x, so x is out. We remain with an x inside there and negative 3 there. Then positive 2 here. So what are we going to remain with here? X. Then 2 into negative 6 is negative 3. Then less than 0. Okay, you can see x minus 3 is common. We take it out. So x minus 3 is common. We take it out. I'll remain with x here. I'll remain with positive 2 here. Less than 0. So at this stage, the examiner is now ready to give us 1 mark. Okay? So we now have 1 mark here. The other one, I said we need to state the roots. At this stage, we are almost up to 2 marks because it will be very easy for us to state the roots. So you write down roots. So what are the roots here? So you set each piece equal to 0. So you set this equal to 0. What I mean is you set x minus 3 equal to 0, then x is equal to 3. You see? Yeah. So the roots, x1 is equal to 3, or if you want, you can just say x is equal to 3, or the other one, x is equal to negative 2, because when you set this equal to 0, it will give you negative 2. So at this point, we have another mark. We've earned ourselves a mark. So we now have 2 marks. So let's now fight for the 3rd mark to make it 3. Okay. So what are we going to do now? Remember I said you're not finding the exact value here. You're finding the set of values of x for which this expression is true. Or if you want, you can say for which this expression is true. X squared minus x minus 6 should be less than 0. So which values of x can be substituted in there such that the result will always be less than 0? So let's test. So I'm going to draw the number line. Our critical values, we have 2 critical values. We have negative 2 and 3. So I put them there. Okay, now that I have these 2 critical values, I have created 3 regions that I want to inspect. Okay, so let's inspect these 3 regions. The regions I'm talking about, students, are these. We have this region, 1. So this region where we are less than negative 2, this side. We also have another region in between negative 2 and 3. So this is region number 2. Region number 3 is above 3. I'm sure you can see it here. Okay. So we want to test which values of x can we be using such that when we put them there, okay, we substitute them there, the result will always be less than 0. The result will be negative, because something that is less than 0, something that is less than 0 is negative. Okay, yeah. So let's test. But how do we test? We simply pick random values from the regions that we have. So we just pick random values, then we try to test and see whether the result will be negative or positive. And if it's negative, we know it's less than 0. If it is positive, then it's above 0. Okay. So this is what I mean. So first of all, you write down this is your number line. Okay. Yeah. So let's test. So in this region, which number you can pick any number here. So for example, maybe you can pick x equal to negative 3 here. Okay. So what do you do with this value? You simply get it. And this is why we factorize the expression to make our work easy. Okay. Factorizing the expression makes our work easy because we'll be able to substitute there and simplify. Okay. Very easy. Okay. Yeah. So you get negative 3, you put it there. You're not interested in the value. You're only interested in whether the result will be negative or positive. Okay? Yeah. So I get negative 3. I put it here. So you can simply do this in your mind. So negative 3, you put it there. You also put negative 3 here. Okay? So you can see negative 3 minus 3 is negative 6. But I'm only interested in whether it's negative or positive. So negative 3 minus 3 giving me negative there. Negative 3 plus 2 giving me negative there, because negative 3 plus 2 is negative 1. So if I get negative 3, I have a negative there and I have a negative there. But take note, these two expressions are multiplying, okay? They are multiplying. So we have a negative there and a negative there. So negative multiplied by negative will give us positive. It means that any number that I get from this region will always yield a positive result, okay? Yeah, I hope that is clear. So this will give me positive here. You can put the positive there. Okay. Then let's now go in the middle between negative 2 and 3. The easiest number to use here is 0. Okay, so we have x equal to 0. If you want, you can use x equal to 1, you can use x equal to 2. All those numbers are in between negative 2 and 3. But 0 is easy to work with. So if x is equal to 0 here, let's see what will happen. What will be the result there? So you put 0 there. Okay. What I mean is you put 0 here. You also put 0 here. So 0 minus 3 is negative 3. So in other words, we have negative there. 0 plus 2 is positive 2. In other words, we have positive there. So we have negative there and positive there. So negative times positive, negative. So in between negative 2 and 3, the result will always be what? Positive. No, I mean negative. So we're getting negative there. Because we have a negative there, then positive. Negative times positive is negative. Then let's now go there. So if you look at this region now, so this region, we are looking at numbers that are above 3. So which number can I use? If you want, you can use infinity, positive infinity. You can use 100, okay? Yeah. So let me just use 4. So x is equal to 4 there. So I put 4 there, I put 4. So 4 minus 3 there is positive 1, so positive. 4 plus 2 is positive 6, so positive. So you can see that positive times positive will give us positive. So we have positive here. Now, these are our results. So which one will be the best range of values of x? So let's come back to this. It says we're looking for the set of values of x for which this expression is less than 0. And I said anything that is less than 0 should be what? Negative. So where do we have negative? Here. So in between negative 2 and 3. So it means that for us to make this expression valid, we need to be using the values that are between negative 2 and 3. So x should be between negative 2 and 3. It should be above negative 2, but less than 3. Okay, so we now write down the range. So therefore, we conclude the range of values of x here. Or if you want, you can just say therefore. So what is the correct answer here? So x should be between negative 2 and 3. It should be above negative 2, but less than positive 3. So negative 2 less than x less than 3. So this will give you what? The correct range of values of x. Okay, so this will give you another mark, and in total we have 3 marks. So this is the final answer. I hope you got it. Okay, so let's go to the next question and see what we're supposed to do. I'll also share with you another method, probably the simplest method. Yeah, if you know how to sketch the graph of a quadratic function. Yeah, so find the range of values of x for which 2x squared minus x minus 15 is greater than 0 this time. Okay, it's the same thing. Let's just follow the same 3 steps. So step 1, I said you need to factorize. We don't need to rearrange here because it's already been arranged in the standard form. So let's just factorize. So let's look for the product, the sum, and the factors. So product, 2 times negative 15. I said it's a times c, okay? So 2 times negative 15, we have negative 30. The sum, again, you can see it's negative 1. So factors, your focus is on negative 30. Numbers that can go into negative 30. Okay, so you just take maybe 30 seconds or I don't know how, just, yeah, less than a minute to think of these factors. Yeah, so we're going to have negative 6 and 5 because negative 6 by 5 is negative 30. Negative 6 plus 5 is negative 1. Then, as usual, we write down these in terms of x. They should replace this part. So we're going to have 2x squared minus 6x plus 5x minus 15 greater than 0, like that. Okay, so here we factorize. So we can see 2 and x are common. So we shall say 2x is common. So what will remain there is x. Uh, 2 into negative 6 is negative 3. X is out, so we don't have x there. Then positive 5 is common here. So what remains there is x. Then 5 into negative 15 is negative 3. Greater than 0, like that. You can see x minus 3 is common. So x minus 3 out. Then what remains here is 2x plus 5. Okay. So at this stage, as usual, we have 1 mark. Okay. Then we write down the roots. So we solve for x. So you can see here. So x is equal to 3 here. Or, so you solve for this one. So we have 2x plus 5 equal to 0. So 2x equal to negative 5. Or x is equal to negative 5 over 2. Like that. Okay. Or you can write this if you want as negative 2.5. Like that. Okay. So we now have this one. So x is negative 2.5. Okay. Then what else now? So again, another mark here. So we have 2 marks so far. So the last step is to test. Okay, so we have negative 2.5 here. Okay, let me just write it as negative 5 over 2 for now. Or if you want, anyway, let me not confuse people, which is negative 2.5. Then 3 there. As usual, we have 3 regions. This region, and that region. So we test, okay? So let's start with this one. So here I can pick any number, maybe x equal to negative 3 here. You can see negative 3 is in this region, okay? So we use negative 3 and substitute for x there. So you have negative 3 there. So to be negative 3 minus 3, negative 6, so we have a negative there. Then you put negative 3 here. So when you put negative 3 here, it will be 2 times negative 3, which is negative 6. Then negative 6 plus 5 is negative 1. So we have negative 1, negative 6. So we have negative there. So we can see that here we have what? Positive. Okay, let me try to use a different color. So this is positive. Okay, we go there. So which number can we choose here? Maybe 0 again. Okay, so x is equal to 0 here. So you put 0 there. You can see if you put 0 here, it will be negative 3. You put 0 here. 2 times 0 is 0. Plus 5 is 5. So we have positive 5. So we have negative 3, positive 5. So we have negative there and positive. So negative, positive, negative. So what we have here is negative. Okay. Yeah. Then we test here. Which number can I use? Again, let me choose 4 here. You can choose any number as long as it's above 3. Yeah. So you put it there. So 4 minus 3 is positive 1. You put 4 there, you can see that whatever you put there, it will always be positive. So positive times positive there will be positive. Okay. What are we looking for here? We're looking for the range of values of x for which this expression, okay, or if you want, you can say for which this expression, this and that are the same. Such that this one is the factorized form of this expression. They are literally the same thing. So we're looking for the range of values of x for which this expression or this one is above 0. And something that is above 0 should be what? So if it's above 0, it should be what? Positive. Okay, a positive number is greater than 0. So we're looking for the regions where we've achieved or we now have positive results. So where do we have positive results? So it's this and that. So you can see that x here should be less than negative 1 over 2. So we're looking for anything that is less than negative 2.5. Or x should be above 3. Should we get anything in between negative 2 and 3? No, because this will make our expression invalid. If we pick anything in between negative 2.5 and 3, this expression will be negative. What we want is something that is above 0, positive. So it's this region and that region. So let's conclude. So we're going to say therefore, so x, so here we should have x, we should also have x there. Okay, so x should be, you can see it's less than this and it's greater than there. Okay, so x should be less than negative 2.5. So therefore, x is less than negative 2.5, like that. Or we can also pick this one, or x should be above 3. So this is your answer, and that is how you write it, okay? Like that. So you get 3 marks. Okay. Let's go to the third and the last question here. Then I'll also explain how you can actually handle these questions based on just sketching, okay? It's very easy when you sketch. Okay, as usual, we need to factorize it, but you can see it's so messy. So we have to just clean up some things here. So first of all, let's expand, we rearrange and things like that. So x times 7, so we have 7x. X times negative x squared. Then we can actually take this to the other side. So it will be minus 6, then greater than or equal to 0. Okay. So actually when we say greater than or equal to 0, it means that the roots that we are having, okay, I'll explain in just a moment. I'll explain what it means here. Okay, so let's now rearrange it. Remember, I should have something like this. So this time around, we should have something like that. Okay, so let me start with this one. So it will be negative x squared, then this one plus 7x, then minus 6 greater or equal to 0. Okay, so we now factorize here. So let's look for the product, the sum, and the factors. So product, negative 1 times, you can see it's a times c. So a this time around is negative 1 times c, which is negative 6. So that will give us positive 6. Then the factors, the sum is b, which is 7. Okay, so factors, we're looking for 2 numbers. When we multiply them, we should get positive 6. When we add them, we should get 7. So those numbers will be 1 and 6. You can see that. 1 and 6, because 1 times 6 is 6. 1 plus 6 is 7. So we now write them in terms of x. So negative x squared. So this will be 1x, or I can just say x. Then this one plus 6x, then minus 6, like that. Okay, so what we have here, so you can see that we take out negative x here. Okay, so negative x here out, so negative x out. So what will remain here is x. Okay, take note, when you multiply negative x times x there, will give you negative x squared. Okay, then this negative and that positive will give us negative there, because you want to divide that into that. So x into x now is 1, like that. Okay, then what is common here is positive 6, like that. Then positive 6 is out, we're going to have x, then minus what? 6 into negative 6 is negative 1. So negative 1, like that. So greater or equal to 0. So you can see x minus 1 is common. So we're going to have x minus 1 common. So what will remain here is something like this, negative x, right? Then plus 6. Okay. If I want, I can just rearrange this and say, let me start with 6, then minus x. It's the same thing. Okay. So let me just write this as 6 minus x. It's the same thing, please. You can write like that, or if you want, you can write like that. Yeah. I just want to hide the negative. Okay. Then is greater or equal to 0, like that. At this stage, we have 1 mark. Let's now write down the roots. So the roots. So we solve for x. So this one will be x minus 1 equal to 0. You can see we're going to have x equal to 1. Or we solve for this one. 6 minus x equal to 0. We solve for x, it means 6 minus x equal to 0. So x can go there. So x6 is equal to x, or x is equal to 6. Okay. Then after that, we now test. Like that. Okay. So what we have is 1 and 6. Like that. So let's test. So we pick any number here. You can see anything that is to the left of 1. We can pick it. Maybe I can pick 0. In between 1 and 6, I can pick 2. And here I can pick 7. Okay. So we now test them and see which signs we're going to have. So x equal to 0. So we put 0 here. So we put 0 here and 0 there. So 0 minus 1 is negative. 6 minus 0 is 6, which is positive 6. So we have negative there and positive there. We're going to have negative. So this one is negative. So we get 2. So I put 2 there. So 2 minus 1 is positive. 6 minus 2 is still positive. So positive times positive will give me positive. Okay, then 7. I put 7 there. What do we have? Okay, yeah. So 7 there and 7 there. So 7 minus 1 is 6, which is positive 6. 6 minus 7 is negative 1. So we have positive there and negative there. When we multiply the two, we have negative. Okay. But what are we looking for here? We're looking for a region where our expression, this expression, should be greater than 0. So where it's positive. So where is it positive? It's positive between what? 1 and 6. So we're looking for this region here. Okay, but this time around, you can see that 1 and 6 are also part of the solutions because of this greater than or equal to. So it means that at this point, it can also be equal to 1. It can also be equal to what? 6. So we're actually shading this part to mean that they are also included. So we're looking for this region. So x should be between 1 and 6. So how do you write down the range here? So we're going to say, therefore, x should be above 1 but less than 6. So we have 1 there, less than x, so less than or equal to, and less than or equal to what? To 6. So the less than or equal to signs here mean that even the critical values now, the solutions, the roots are also part of the solution set. Okay, so I hope you got that. So we now have our 3 marks here, and this is your final answer. Okay. So let me take you back and just show you another method, the simplest method that you can use when you know how to sketch. Okay. Yeah. So for example here, so remember here we found the roots to be x squared. So once you factorize, you reach this stage, you find the roots. You have x equal to 3, x equal to negative 2. You look at this function, this part of the function here. Okay. Quadratic function, okay, you can see that here the value of a, so a here, the value of a is greater than what? 0. So every time a is above 0, the sketch, this parabola, the parabola will curve upwards like this. Okay, it will curve upwards. Okay, but if a is less than 0, it should open downwards like that. Okay, yeah. So if you look at this function now, once you find the roots like that, you know that, oh, because a is greater than 0, it opens what? Upwards. So because it opens upwards, you're going to have something like this. Okay? And where it cuts here, these are the roots that you found. So which ones are the roots? We have negative 2. So negative 2 should be here, and 3. Now, how do we find the range from the sketch? So you can easily picture, you can easily visualize the range from the sketch. You're looking for a region where we are less than 0, where the graph is below 0. So if you look at this, the graph is like this. Okay, it gives you, values, right? Yeah. So anything above 0 is positive. Then this part is below 0. So if it's below 0, it means that it's negative. Okay, so what we had here, we're looking for something that is below 0 because it should be less than 0. So less than 0 means anything below the graph, the function below here, below 0. So we're looking for any value that is between negative 2 and negative 3. You can see will give us functions, values that are down. So any value of x that is between negative 2 and 3 will take us down there. Okay, yeah. So meaning we're looking for these values here. So x should be between negative 2 and 3, like that. So that is why this was our range. If you look at this other one, okay, so we factorize, then we reach this stage. You can see again here, because a is 2, so it's above 0, so it's greater than 0. So again, the graph will open like this, okay? And which ones are the roots? So these are the roots. So because we have our roots like that, so it opens like that. So we have our roots negative 2.5 here and 3 there. This time around, we're looking for a region now where the set of values of x, which will make us have a value above 0. So above 0, it means that you can see, have you seen that the graph here it's above 0, here it's above 0. Anything between negative 2 and 3 will take us down. It will take us down. So if we get values between negative 2 and 3, we'll be getting negative what? Values. So it means that this will be invalid. You are looking for the set of values of x that will make us go up, that will make us have values above 0. So values above 0, it means that we need to take these values, we need to move from there. So anything from there, if I take any value of x in this region going like that, you can see that I'll be going up, which is positive, which is above 0. Again, anything from there going like that, it will also take us up. I'll be getting values that are positive, greater than 0. Meaning x should be in this region or that region. So x should be less than negative 2.5, which is what you have here. Or x can also be above 3, which is what we have here. Okay, I hope you understand that. Yeah, let me also explain the other one. Okay, so this time around, we had our roots. Which ones were our roots? Okay, so we had this one and that one. So if we look at our function now, so come close. Have you seen this part? Okay, so you can see this time around, x is actually negative 1. So x is negative 1, it means it's less than 0. And if it's less than 0, it means it should now open downwards like that. So if it opens downwards, so we have something like this, then it opens downwards like that. Okay, but where it cuts here, these are the roots I'm talking about. So which roots do we have? We have 1 and 6. So because we have 1 and 6, and what are we looking for? We're looking for where this expression is above 0, okay, greater than or equal to 0. So it means it includes the roots themselves. Okay, greater than or equal to 0. So if it's greater than or equal to 0, where is the graph above? You can see the graph is above there. Okay, so it's above in this region. Okay, so if it's above in this region, it means that we need to take values that are between 1 and 6. So values that are between 1 and 6. And they include 1 and 6 themselves because of this part. So I shared this. So in this case, it means that x should be between 1 and 6, which is what we had there. Okay, I hope you understand this, and if you're good at sketching these things, it will be very easy for you to visualize all these things. So I hope you understand all these concepts, and if you found this video helpful, you want to share with your friends that would also be in need of this video. And don't forget to follow our page for more of the same videos. Bye-bye.